Hey guys, I'm going to be explaining a question from our textbook. It's question 4 in chapter 19, which is a question about using the right hand rule and calculating magnetic force, which some people are still confused about. So here's the question. A positive charge moves horizontally to the right across this page or slide and enters a magnetic field directed vertically downward in the plane of the page. A. What is the direction of the magnetic force on the charge? B. If the charge is 0.25 coulombs and its speed is 2.0 times 10 to the power 2 meters per second and it is acted on by a force of 20 newtons, what is the magnetic field strength? Things we need to know to solve this question are obviously the right hand rule, which states that if when you use your right hand with your thumb pointing the direction of the current or the velocity of the particle, and your fingers pointing the direction of the B field or magnetic field, your palm will face in the direction of the magnetic force. We also need to know formulas for part B of the question. F equals I, which is the current, B, magnetic field, and L, length of the wire, sine theta. And F equals Q, which is a charge, V, velocity, and B, again, magnetic field of the object. Now, part A, direction of the force. So, the problem gives that the direction of the current is horizontally to the right. The direction of the B field is vertically downwards. Now, if we position our hands with our thumb pointing to the right and our fingers pointing vertically downwards, now our hand appears to be in a slightly awkward position with our palm facing horizontally upwards, not vertically upwards, but horizontally upwards in the same plane as the direction of the current. This is the answer to part A, and that the magnetic force is horizontally upwards with respect to the page. For part B of the question, it asks to calculate the B field, the magnitude of the B field. Well, we can use our formula that we saw earlier, force equals QVB sine theta. We can rearrange this formula to solve for B, which is B equals F over QV sine theta. Since B and the current are perpendicular to each other, theta equals 90 degrees, and sine theta therefore equals 1. The givens were Q equals 0.25 coulombs, B equals 2.0 times 10 to the power 2 meters per second, and the force equals 20 newtons. Therefore, if we plug in the numbers into the formula, we get that B equals 0.4 T. So this is basically how you solve a simple right-hand rule and calculation question. Some tips, of course, are to make sure you know how to use the right-hand rule properly and to keep your palm flat with the direction of the magnetic field known and the current known so that your palm can point in the direction of the magnetic force.